Hello ladies and gentlemen, we're going to do a quick review of coordinate geometry. We're going to go over distance, perimeter, and parallel and perpendicular lines to points and lines there. So let's start with getting distance between 2 points on a graph. When it's on a graph like that, you need to turn this into a right triangle, and we're going along these grid lines because those are easy to count. You can go that way or you can go this way. Both are fine. You just need to count how tall your triangle is and how wide it is. This triangle is 5 tall and 6 wide. And now I'm going to use my Pythagorean theorem. This side is C, the other two sides are A and B. It doesn't matter which one is A and which one's B, just one is A and one's B. And so your Pythagorean theorem is A squared plus B squared equals C squared. And we're going to plug the numbers in. We got 6 squared plus 5 squared equals C squared. Compute 6 squared, that's 36. 5 squared is 25. If you add those together, you get 61. But that's C squared. We don't want C squared, we want just plain old C, and so we have to square root it. So we're going to get the square root of 61, and that is going to be some infinitely long decimal number. Don't actually write that whole number, just round it up, and let's round to the first decimal place. Round your answers to the nearest tenth. That's the first decimal place. And so we're going to round here. We got 7.8102, etc. like that. To round to the 10th place, we got to look at the 100th place. If that is 5 or bigger, we round up. It is not, and so we're just going to cut it off. You're looking at about 7.8 on this one. If you're just given 2 random points, you do the same thing, but algebraically. To figure out if we were to draw this, let's do a quick sketch. -8, -5 is over here somewhere. 0, 2 is here-ish. We get a little drawing like this. To get how tall your triangle would be and how wide it is, you just need to subtract your y's and subtract your x's. So if you subtract your x's, that tells you how wide this triangle is. Well, if we just do -8 minus 0, you get -8. But it's a distance, and so we're not going to put the negative part on it because distances are never negative. If we do -5 minus -2, we get -7. And again, distances aren't actually negative, and so we're going to do that. So that's how tall, that's how wide and tall this triangle is. We need to now square these because these are the A and B values. We're trying to get C. And just like our last problem, you'd have to square root this answer anyway. And I'm just going to put the whole thing in right now. So square root of 8 squared plus 7 squared. And I'm going to get about 10.6301, etc. To round to my 10th place, I gotta look at the 100th place. That number's just 3, which is not 5 or bigger. So I'm going to just round it off. And we got 10.6. Nice. So that's how you get distance. To get perimeter of a shape, you have to figure out how far it is around the shape. Some of the sides are going to be easy to count, like this one. That's just 3. These ones that are diagonal, you have to do distance formula twice. So you're going to draw your triangle here. It's 1 wide, 2 tall. So to get this distance here, it's going to be the square root of 1 squared plus 2 squared, which is the square root of 5, which is going to be about 2.2. So I got that one. And then to get this one here, again, I'm going to turn this into a right triangle. This triangle is 2 tall and 4 wide. So its distance is going to be a square root of 2 squared plus 4 squared, which is going to be a square root of 20. 2 squared plus 4 squared, which is about, about 4.4721, etc. Since this number, the 100th place, is 5 or bigger, I actually need to round up. So it's going to be about 4.5. Now I have my 3 distances. To get my perimeter, I need to add them all together. So you do 4.5 plus 2.2 plus 3, and you get an answer. 4.5 plus 2.2 plus 3. And you're looking at 9.7. So this is about 9.7 perimeter on that shape. So that's how you get distance. That's how you get distance if it's not on a graph. That's how you get perimeter, which is distance all the way around. And now we're going to get equations of lines that are parallel or perpendicular. Remember, parallel slopes are the same, and perpendicular ones are opposite reciprocals. An opposite reciprocal means you flip it upside down and you change the sign on it. So let's start with a parallel line. To get all of these equations, we're going to use point-slope form, which is y minus y1 equals m times x minus x1. The y1 and x1 are just the x and y coordinates from the point you're trying to go through, and then the slope is the slope you would need for a parallel or perpendicular line. And so for this particular situation, when you look at our original line, find its slope, which is this one, negative 2/3. And since we're looking for a parallel line, we're going to use the exact same slope. And then when you look at the point we're trying to go through, the first number is x1, the second number is y1. So I'm going to put the x in the x spot, put the y in the y spot, and fill in my equation. We got y minus negative 3. I don't need parentheses. And then the slope we're going to use is the same one that's in our original line. So we're going to use negative 2/3. And now we got x minus my x coordinate there, which is 3. And now I have this equation. The rest of this is simplifying it. When you subtract a negative, same thing as add positive. So we got y plus 3. We're going to distribute negative 2/3 here. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 3 is going to be positive 2. And that's it. These 3's are going to cancel each other. You would get positive 6/3, which is still just 2. Okay, from here, we're just going to get y by itself, so subtract that off. And now we got y is negative 2/3 x minus 1. And we got that equation. Okay, for my next one, I want to get an equation of a line that's perpendicular to the original. So I'm going to take my old slope, and I'm going to flip it upside down, and get rid of sign change. So that's my slope I'm going to use for a perpendicular line. Everything else is the same. I still got y minus the y coordinate of the point I'm trying to go through, which is 2, negative 2. And it's going to equal the slope I'm going to use, which is this negative 7/5. And then I got x minus the x coordinate of the point I'm trying to go through, which is 5. And now I go through my simplifying process again. Subtracting negatives, same thing as add positive. I'm going to distribute my negative 7/5. So I got negative 7/5 x, and then plus 7 there. Again, you can use a calculator to help you out with that little computation there. And now we're going to subtract the 2, and we got y is negative 7/5 x plus 5. And problems over. Hopefully you find that helpful and you can learn the things you need to learn for coordinate geometry.